this video, I would like to solve a very complex definite integral without using any integration techniques. This integral is given by the integral of log sine x dx over the interval from 0 to pi over 2. First thing, let's give this integration a name, and we call it I. To solve this problem, let's focus on the argument of the logarithm, which is sine x. And we know sine x on the interval from 0 to pi over 2. Let's draw that function. So there's a maximum value of 1, and from 0 to pi is given by this. That's approximately 1. And this midpoint is pi over 2. Also, so this is the sine function. So one can notice that cosine is also defined from 0 to pi over 2 using this function cosine of x. So you can see that the integral from 0 to pi over 2 of the logarithm of sine x dx is also equal to the integral from 0 to pi over 2 logarithm cosine of x dx. This is shown geometrically, and one also can show this mathematically. It's easy by knowing that on the integral from 0 to pi over 2, we have that sine pi over 2 minus x equal to sine x, and we know that this is also equal to cosine x, and this is true for all values of x belongs between 0 and pi over 2. So, considering this fact, we can write double I, so 2 times I is equal to I plus I, where the first I belongs to the original integral, plus the second integral is given by integral from 0 to pi over 2 log cosine x dx. Now let's combine then two integrals. So this will be integral from 0 to pi over 2 logarithm of sine x plus logarithm of cosine x dx, and using the logarithm property that logarithm a plus logarithm b is equal to logarithm of a times b. So doing that, we have this integrand here can be written as the logarithm of sine x times cosine x. And using the trigonometry property, which says that sine double angle is equal to 2 times sine x cosine x, and of course we can divide by 2 and divide by 2, so we will have sine x cosine x is just equal to half sine 2x. So that will be equal to, so the integral from 0 to pi over 2 log sine 2x divided by 2 dx. And now, using the property of the logarithm, which says that logarithm of a over b is logarithm of a minus logarithm of b. So this case we have now the integral from 0 to pi over 2, the logarithm of sine 2x dx minus integral from 0 to pi over 2 logarithm of 2 dx. Now this is easy to integrate, which is just pi over 2 log 2. That's the integral of a constant. Now here, what we can do is we can do a change of variable. So we let u equal to 2x. So in this case, we will have x equal to u divided by 2, which means that dx is just du over 2. And then when x equal to 0, u equal to 0, when x is pi over 2, then u is just 2 times pi over 2, which is pi. So in this case, this integral becomes equal integral from 0 to pi. These are the new limits. And the logarithm of sine u and dx is just du divided by 2 minus pi over 2 log 2. So now notice that this is a constant, can go out the integral, so we will have 1/2 integral from 0 to pi of logarithm sine u du minus pi over 2 log 2. Now, if you go back to the sketch of the sine function, it's clear that the integral of log sine u from 0 to pi over 2 is equal to twice. So this is equal to twice the integral from 0 to pi over 2 log sine u du. So, and we know that this is just the integral I, the original integral. So in this case, 2I equal to 1/2 multiplied by 2 times I minus pi over 2 log 2. So this just equal to 2I equal to I minus pi over 2 log 2. Taking this I to the other side, then I will have I which is equal to the integral from 0 to pi over 2 log sine of x dx equal to minus pi over 2 log 2, or in a positive quantity expression, this is log of pi over 2 1/2. So, but the integral has a negative value. So if you want, you can express it like this or like that. So here we go. This is how we can do a complex definite integral without using integration. It's a very interesting special case. Thank you.